All right, so let's go back to something pretty basic to learn this. All right, you'll get this. This is actually really easy, so just watch. So if I did 5 times 3 plus 8, do you remember when I first taught you the distributive property, I said, well, that means you just have to do the 5 times the 3 and add it to the 5 times the 8, right? So remember doing that? I never made you show this step after you first, after you learned it. Okay, and that's all we're really going to do. We're not going to, it would be 15 plus 40, whatever. So do you see that what they have in common is a 5? Okay, so if they have the 5 in common, you really only need to write that 5 once. And then after I pull that 5 out, it's 3 plus 8 that's left, correct? So if I had 4 times 7 plus 4 times 9, what do you see that they have in common? 4. So you pull that what they have in common out, and you only need one of them. And then what's left? 7 plus 9. This is the basic way that the distributive property works. If I give you something, you have to recognize what's in common, pull that out, and say, oh, that just means they must multiply 7 plus 9 times 4. Instead of doing it twice, they did it once. So, are you ready for now this? So if I take 2x and I want to multiply that by x plus 4, then I want to, not add that, we'll do subtract. We'll say subtract. Subtract that from 3 times x plus 4. Do you see what they have in common now? It's not one number. It's a binomial that they have in common. It's the whole x plus 4, right? So let's do what we did up here. Let's pull that x plus 4 out. And then what's left? 2x minus 3. That's it. So do you see your x plus 4 as your common factor that was pulled out of there? Okay. So here's what we're talking about. Remember what factoring means? Factoring means this is the answer. What did I multiply to get that answer? I multiplied the x times the 4, or x plus 4 times the 2x. Then I multiplied the x plus 4 times the negative 3. And that's what you factored. These are the two factors of that product. Got it? Okay. So let's try this one. 4a times a plus 1 plus 3 times a plus 1. Okay? Real simple to start out with. What does it look like it has in common? So this is the answer I got, which means I must have multiplied an a plus 1 times what? Times a 4a plus 3. That's it. Okay? So you mean to tell me if I were to distribute this out, I'd have a plus 1 times 4? Yes, and a plus 1, or times 4a, a plus 1 times 3. Now, I know what you're thinking. We haven't foiled, then we would have to FOIL this through, right? Or distribute that through, okay? So now watch what would happen if that's what you got. You would get an answer that looks like this. Okay? If I distributed the 4a to this and the 3 to this, there would be no like terms, and I would just have something that looks like that. Okay, so now moving on to the next step here. Factor that. What? You're looking at that thinking, what? My goal is, what 2 binomials did I multiply to get that as an answer? Well, how we're going to do this is factor by grouping. So check step number 1. Is it in standard form? Standard form means what? Highest exponent to lowest, constants at the end. That's how we need it, okay? So now we're going to group together, but watch very carefully what I grouped. I'm going to leave that middle sign, which I know that you know that 5x is positive, but you got to just kind of keep that sign in the middle. So you want to do this plus this first. This is how we're going to find those 2 binomials that we multiplied to get that. Now, you're looking at this as two separate problems. Go back to 9-4. Is there a GCF in there? What's the GCF of the first set? An x squared, right? So pull that GCF out and tell me what you're left with. Meaning I pulled out, there's no number here. I pulled out the x squared because it's the lowest. What would need to be here? X, and then just the plus 3. Do you see why there's no x's here? Because there's a squared, and I already have it pulled out. Now, what can be pulled out of the 5x plus 15? A 5. So put that plus sign, pull the 5 out, and watch what happens. What's left here? X plus 3. All right, and what do you notice? X plus 3 is the same. Every time you factor by grouping, this should happen. If it doesn't and your parentheses end up different, you did something wrong, okay? Probably because the whole point of having factored by grouping is they're set up to work out this way. Does that mean that as soon as you find the first one, it's okay to just recopy it and do the second one? No, because what if you factored this one wrong? So you should always do it and then double check it. This is 5x plus 15 checks. So now what do? What does it have in common? Your x plus 3. And what do you multiply that x plus 3 by? X squared plus 5. So I just factored. The goal, the learning target was to figure out what two binomials I multiplied to get this crazy mess of an answer. And to do that, when you factor with 4 terms, you factor by grouping. So I just grouped these two together. I grouped these two. I pulled out the GCF, which we practiced in 9-4, and then I grouped them together like that. Okay? So let's try this next one. X to the third minus 6 plus 2x minus 3x squared. Okay? So do you remember? I should have had you write it down. I'll have you write it down now. What did I say is the most important thing before you can factor? You have to make sure it's what? Like, it's in standard form. And right now it's not. Okay? So the highest exponent, and what property allows us to move these around however we want? The order doesn't matter. The commutative property. So as long as I move these signs, what should come next? That 3x squared and it's negative. Then the 2x is positive. And then the negative 6. Okay? Now that I have it in standard form, group. Group the first two together, group the last two together. Keep that sign in the middle there. So off to the side somewhere so you have it to look. I want you to put, you must put in standard form. What's the degree of this polynomial? Anybody remember? 3, because it's the highest exponent. So it's highest exponent down to lowest. Okay, with the constant. So just a reminder of what standard form is. Now let's factor out. So put in standard form. You want to group the first two together, and then you're going to group the last two together, keeping the sign in the middle. And then what would you say we did next? You do what with each set? Factor out the GCF of each parenthesis. Factor out each GCF. So let's do that now. Let's look at this. That leaves me with what? An x squared. And what's left? This is like a really important part. What's left here that would multiply to get that as an answer? X, because remember you add your exponents. So I'm expecting to get an x minus 3, but I better just do it just in case to make sure. What can be pulled out of 2x and 6? A 2, and what are you left with? X minus 3. We're not done yet because now I have my common factor, which is an x minus 3. And what do I multiply that by to get the x squared? X squared plus 2. So, how do we figure out when we're starting with the answer how to get the products? You factor them by grouping. So factor out each GCF, and then you pull out the GCF of that whole thing, and then rewrite it, okay? Now, let's take a look at this one. This one's a fun one, okay? It's kind of got you thinking something. H to the third plus 4h squared minus 25h minus 100, okay? Is it already in standard form? Yes. So go ahead and go right to grouping. I want you to try this for a minute. Be careful. I want to see what you get when you pull that out. So go ahead real quick on your own and let's see if you catch this. If something tricky happens. So what happened? You knew that it was okay to pull out, that looks like an N, that's an H squared, and you're left with an H plus 4. That is a minus. What do you pull out of 25 and 100? A 25. H. Now be careful because you know it has to match up. Don't just assume that this sign always gets brought down, right? If the product is a negative 100, you multiplied a negative times a positive. What number needs to go here to multiply basically a negative 25 times what is a negative 100? Only one of them can be negative, and my 25 is, which means the 4 must be positive. All right? Now you see what you have in common. We grouped them together. You have your H plus 4 that you're going to pull out. And then you have your H squared minus 25. And you probably think you're done. But you're not. Because if you remember back to the quiz 1 week ago we took before you left for DC, it had to do with special cases. And when I FOILed out, like, say, a 5a plus 6 and multiplied it by a 5a minus 6, you had a 25a squared minus 30a and a plus 30a, and then a negative 6 times a positive 6 was a, and then those canceled, and your answer was 25a squared minus 36. Some of you didn't take that quiz, you'll have to. But do you remember that? The middle term canceled. Is that a perfect square? Yeah, I multiplied by 5a. Is that a perfect square? Yeah, I multiplied 6. So you have to know that, oh, that must be this one, right? So does either one of those look like it might be? Nick? Question. This 100? Well, this was the problem that's given. Negative 25 times positive 4 is negative 100. I'm not sure. I know what you're asking. I don't know what you're saying right here. So this would have to be a... No. This is the problem. This is the way. This is the answer. The answer worked out to be this. There's no changing this. I see what you're saying. You're thinking you're distributing that, but you're just grouping them off. This is, yeah, the parentheses that I put weren't there in the beginning of the problem. I put them there as a problem to use. I see what you're saying. So no, this is the answer. It's kind of like saying, of all these problems we did, you know, that should have been a plus. Well, that's the problem. The problem was given. I see what you're saying, though. So no, you don't distribute it when you factor by grouping. You pull it out. So now, what would, if I have my H plus 4, what would that, we haven't done this yet, but we're going to this week, what would that factor into? Remember, difference of two squares? What must I have started with if my answer is h squared minus 25? An h times an h, a 5 times a 5. And what's the only way to get that middle term to cancel? A positive and a negative. Here's where we're at. We didn't talk about that yet, but that's going to be the answer in the back of the book. You're going to think it's going to be that answer, and you're partly right, but we haven't taken this further down yet. So you may see that, and if you recognize it, you are going to be ahead of the game if you break it down into this. So this factored into that, didn't it? So be on the lookout for that. And again, if this is a problem in the book that has an equal 0 there, then just make that your answer, and we're going to pick up later why that should be, why that is going to be what it is. Okay? So